Good morning and welcome to this video for the 2020 Level 2 Calculus paper of 2020. So question 1. A function is given by f of x equals to x cubed minus 2x squared plus 5. Find the gradient of the graph at the point when x equals to 4. Right, so this is the question that comes every year. It's always an achieve level question. It's always the first question. And the first thing you gotta do is just you gotta differentiate the function to find the gradient function. And then you plug in the x value for that gradient point, and then you can find the gradient at that x point, okay? So to differentiate this, we're going to be using the power rule, okay? So we're going to multiply by the power, so x cubed, so 3 times 1 at the front here, so 3x, take the power down by 1, so 3 minus 1 is 2, so 3x squared, minus do the same thing here, 2 times 2 is 4, take the power down by 1, and 5 is independent of x, so it just goes away. So f dash of x equals to 3x squared minus 4x. F dash of 4 equals to 3 times of 4 squared minus 4 times of 4. And that should give us an answer of 32, which should be our final answer for this question, and this should just be an achieve level question. Question B, another function is given by h of x equals to 0.5 x squared plus 3x minus 1. Find the x coordinate of the point of the graph of this function where the gradient is 5. So for this question, we're really just doing the exact same thing as we were doing before, but rather than finding the gradient at the point, we're going to be finding the point where our gradient is 5. So we're going to be carrying out the same process. We're going to differentiate, so h dash of x equals to 0.5 times 2 is just 1, so just x plus 3. Alright, now we're going to substitute the gradient equals to 5, and we're going to find the x point on which the gradient is 5. So we're going to substitute h dash of x, so the gradient is equals to 5. So 5 equals to x plus 3. So therefore, x equals to 2. And that should be another achieve level question. Question C, find the equation of the tangent of a curve y equals to x squared plus 5x at the point 214. So to find the equation of the tangent, we know that the equation of the tangent is written as y equals to mx plus c, where m is the gradient of the point at the point of where the tangent meets the curve, which in this case is x equals to 2. So we're going to be carrying out the exact same process as we were doing in question A, where we're going to be finding the gradient at the point when x equals to 2. So we're going to differentiate y equals to x squared plus 5x. So therefore dy over dx equals to 2x plus 5. And if we substitute x equals to 2, so dy over dx equals to 2 times 2 plus 5, which equals to 9. Alright, so now we know that y equals to 9x plus c, 9 is the gradient. And now we know that it passes through the point 214, so we can substitute that point into our equation of the tangent when we can find our c value. So 14 equals to 9 times 2 plus c. You should find that c equals to negative 4. And therefore y equals to 9x minus 4. That is the equation of the tangent, and this should give you a merit grade. To get an achieve grade, if you can find the gradient of the tangent at the point x equals to 2, you should find an achieve grade there. Alright, so the gradient function of a curve is given by f dash of x equals to px minus 4, where p is a constant. The curve passes through the points 4, 12, and negative 6, 2. Find the equation of the curve. So for this question, we're really just going backwards from what we were doing in part A to C. So we're going to be integrating from the gradient function to our original function. So we know that f of x is equal to the integral of px minus 4 dx. And since p is a constant, we're going to just use that power rule. So we're going to increase the power by 1, and we're going to divide by the new power. So f dash of x equals to px squared dividing by 2 minus 4x. And don't forget the constant of integration plus c. Alright, so now we're going to be solving a simultaneous equation in order to find the equation of the curve. So we know the curve passes through 4, 12, and negative 6, 2. So we can put 12 equals to 12 equals to 4 squared is 16, divided by 2 is 8, so 8p minus 16 plus c. And therefore we can say 28 equals to 8p plus c. if we move the negative 16 to the other side, and that's our equation number 1, and equation number 2 is passing through the point negative 6, 2. So 2 equals to negative 6 squared is 36, divided by 2 is 18, so 18p. Negative 4 times negative 6 is plus 24, and plus c. So therefore, negative 22 equals to 18p plus c. And we also know that 28 equals to 8p plus c. So if we subtract these two equations, we should get negative 22 minus 28, that's negative 50. That equals to 10p. So therefore, p equals to negative 5. And now, p equals to negative 5. So therefore, if we substitute p equals to negative 5 back into one of our equations, let's say we substitute it into equation 1. So 28 equals to negative 5 times 8 plus c. Alright, so okay, so 28 plus 50. So we should find that c equals to 68. Okay, so therefore, p of x is equal to, no, sorry, not p of x, f of x. F of x is equal to, so we have p over 2, so technically negative 5 over 2 x squared minus 4x plus 68. And that's our final answer for this question, and this should be an excellent level grade. If we can find either p is negative 5, if you find either p is negative 5 or c is 68, you can get a merit grade. And for achieved, if you can form one equation, you could get an achieved probably. If you can form one of the two equations, you should get an achieved grade. Okay, so yeah, if you can form one equation, that should get you an achieved. So okay, so just check. So times negative 5 times 18. Okay, that's right. Okay, so question E. A fishing boat is 80 kilometers from its port when it reaches its fishing grounds. Having reached its fishing grounds, the boat accelerates in a straight line directly away from its port as it catches fish. The acceleration of the boat is given by a of t equals to 0.5 kilometers per hour squared, where t is the number of hours since it started fishing. The speed of the boat is 3 kilometers per hour when it starts fishing. So in which hour did the boat travel 11.75 kilometers? Okay, so for this question, we can write down that our a of t, our acceleration, is 0.5 kilometers per hour, so per hour squared. And we can actually integrate, so we know we have our a, v, and s, so we can integrate, and differentiate, Alright, so to go from the acceleration to our velocity function, we need to integrate with respect to time. So for v of t, we need to say we integral of a of t dt, which equals to the integral of 0.5 dt. So v of t equals to 0.5 t plus c, which is constant integration. But we know that the speed of the boat is 3 kilometers per hour when it starts fishing. So when t equals to 0, we know that the velocity was equal to 3, and therefore we can find our c value. So 3 equals to 0.5 times 0 plus c, so therefore c equals to 3. So we can write our velocity function as v of t equals to 0.5 t plus 3. And now we can actually go find our distance function. So s of t, we can integrate again. So s of t equals to integral of 0.5 t plus 3 dt. And this will give us 0.5 t squared over 2 plus 3t plus c. So s of t equals to 0.25 t squared plus 3t plus c. Alright, so the question asks us, during which hour did the boat travel 11.75 kilometers? So between which hours did the boat travel 11.75 kilometers? So we can define the time, this hour, as t. and then the next hour during this hour is t plus 1, okay? So the difference between the distances at t plus 1 and t will be the distance traveled in that 1 hour, okay? So t is that time, and t plus 1 is 1 hour after that time. So between these two times, the difference of the distance is the amount of distance traveled in that 1 hour, and that's going to give us 11.75 kilometers, okay? So we can say that s of t plus 1 minus s of t equals to 11.75. So the displacement at the time plus 1 hour minus the displacement at some time is given as 11.75 kilometers, which is the distance traveled within that 1 hour. So first things first, so s of t plus 1, that will give us 0.25 times t plus 1 squared plus 3 times of t plus 1 plus c. And we say that s of t is equal to 0.5 t squared plus 3t plus c. Right, so if we expand out st of plus 1, so expand this one out, we'll get 0.25 times t squared plus 2t plus 1 plus 3t plus 3 plus c. Alright, so t plus 1, if we simplify this a bit more, we get 0.25 t squared plus 0.5 t plus 0.25 plus 3t plus 3t plus, that's supposed to be 3t plus c, okay, plus c. Okay, so now we're going to find the difference between s of t plus 1 and s of t. So we say that 11.75 equals to 0.5t squared plus 3.5t plus 3, so plus 3.25 minus s of t, which is minus of everything inside bracket, so 0.25t squared plus 3t plus c. So as you can see here, oh, we still have the plus c here as well, sorry. Okay, so plus c and plus c, that'll cancel each other out. We have 0.25t squared, that'll cancel each other out. And we have 11.75 equals to 3.5t plus 3.25 minus 3t. Okay, so it's 11.75 equals to 0.5t plus 3.75. Okay, so now if we subtract 3.75 from both sides, we'll get 8 equals to 0.5t, and therefore 8. So therefore we'll find that t equals to 16. So therefore, okay, so t equals to 16, we found t equals to 16. So therefore, we can say that, oh, sorry, it's not 3.75, 2.25, apologize. Okay, it's 3.25. 3.25. Okay, apologize for that. So 11.75 minus 3.25 on both sides. So apologize. So 11.75. 11.75 minus 3. Alright, so sorry about that. So 8.5 is equal to 0.5t. So therefore, t equals to 17. Okay. So you can say on the 17th hour, the boat traveled 11.75 kilometers. Alright, so apologize for the little mistakes there, but we should get that final answer as t equals to 17, which should give us an excellence level grade. To get a merit grade, if you can find your for merit, merit could be finding your distance equation. That might get you a merit, but maybe you need a bit more, but that might get you a merit grade. To get an achieved grade, you just need to find your velocity function. That should be enough to get an achieved. Okay, so question 2. The graph of the function y equals to f of x is shown on the axis below. So sketch the graph of the gradient function f dash of x on the axis below. Both set of axes have the same horizontal scale. Okay. So this is our f of x, which is our cubic, and we know that f dash of x represents the gradient function of f of x. So first of all, we're going to be finding the x-intercepts. So the cubic is going to become a parabola after we differentiate to find the gradient function. So the x-intercepts of this parabola is going to be where the turning points of this cubic is, because that's where the gradient is equal to 0. So you see this point here and this point here. So f dash of x equals to 0 here, and f dash of x equals to 0 at this point here. So we can just say that this is about, so this first turning point here is about negative 2.5, so we note that one down. So here, so it's about here, and this one, this turning point on the right hand side, 1, 2, 3, 4, it's about 6.5, so 6.5, so it's about here. Alright, so those are our x-intercepts for our parabola, and we should see that this is a positive cubic, okay, slopes upwards. Since this is a positive cubic, we're going to be getting a positive parabola, so this is also going to be a positive parabola. And the only two features you really need is the correct x-intercepts and the correct shape. Okay, so correct shape would just be the positive parabola, so that should look something like this. So we have our correct intercepts at the turning points. Okay, so turning points of the cubic should be our turning points of the parabola, and the shape should be a positive parabola since it's a positive cubic. And in terms of the slope of the parabola, it doesn't really matter. All that matters is just you have the correct shape and you have the correct intercepts, and that should be achieved. Okay, so you have correct intercepts and correct shape. So question B, find the x-coordinate of the maximum point on the curve given by y equals to 2x cubed minus 42x squared plus 240x plus 8. Explain how you know that this point is the maximum and not the minimum point. Okay. So to find the maximum point, okay, we need to differentiate and make equal to 0, because at a maximum, the gradient is equal to 0. So if we have a maximum here, the gradient here is equal to 0, so f dash of x equals to 0. So first thing you got to do is go to find the gradient function by differentiating. So dy over dx equals to 6x squared minus 42 times 2, which is 84x plus 240. Alright, so now we're going to make this equal to 0. And we're going to find the turning point. So dy over dx equals to 0. So 6x squared minus 84x plus 240 equals to 0. Right, so 6x squared, okay. So we can divide everything by 6 to make our lives a bit easier. So x squared minus 84 divided by 6, which is 14. X plus 40 equals to 0. And we should see that we can factor this one into x minus 10 and x minus 4. That equals 0. So therefore x equals to 10 and x equals to 4. So these are our two turning points of our cubic. So x equals to 10 and x equals to 4 are our two turning points. And one of them are going to be a maximum, or one is going to be a minimum due to the shape of the cubic. To find which one is the maximum and which one is the minimum, we've got to use the second derivative test, okay? So second derivative test, we need to differentiate again. So this equals to 12x minus 84. So if the second derivative test gives us a positive, that's going to be a minimum. And if the second derivative test gives us a negative, it's going to be a maximum turning point. So if we try x equals to 10, we'll say try x equals to 10. So d squared second derivative is equal to 12 times of 10 minus 84. So which gives us 36. So this is positive, so therefore this one is the minimum turning point. And if we try x equals to 4, we can say the second derivative is equal to 12 times 4 minus 84. Times 4 minus 84. That gives us negative 36. Since this is negative, this is going to be our maximum turning point. So to conclude this question, we can say that we're trying to find the maximum point. So we can say that therefore 4 doesn't want the coordinates. Find the x coordinates. Okay, so x equals to 4 is the maximum. So x equals to 4 is the maximum. We know this. Since the second derivative is less than 0. And this should actually be a merit level question since we have a couple of steps we have to follow through. So getting a merit will probably be having correct x equals to 4 and correct explanation. To get an achieved grade, you probably need to find the two turning points. The two turning points found, you get an achieved. Question C, the speed of an object is given by v of t equals to 3t squared minus 5t, where t is measured in seconds. What is the object's acceleration when t equals to 2? So to go from the velocity function to the acceleration function, we need to differentiate, okay? So a of t will be equal to 6t minus 5. And all we need to do is plug in t equals to 2 to find the acceleration when t equals to 2. So acceleration is equal to 6 times 2 minus 5, which equals to 7 meters per second. This one should just be an achieved level question, since it's just one step and then substituting t equals to 2. So that should just be an achieved level question. Alright, so the graph of a gradient function f dash of x is shown on the axis below. The point C0 is on this graph. Okay. So sketch the graph of the function f of x on the axis below, given that f of c equals to 0. Okay, so f of c equals to 0, so that means it passes through the point C0. And we also know that since this is a positive parabola, when we integrate it to find our cubic, we're going to be finding a positive cubic. So the cubic should be sloping upwards. So that's what we know. We also know that the turning points of the parabola is also going to be, sorry, not turning points, the x-intercepts on the parabola, which is this point here, C and something there. So these 2 points are going to be our turning points on our cubic, and it's going to be sloping upwards. So those are the 2 points we need to remember, as well as the graph that passes through the point C0. So first things first, the graph passes through this point C0, which is also a turning point, okay? And we also know the second turning point is going to be at this point here. Right, so that's our second turning point of our cubic. Our first turning point is going to be at C0, so first turning point is at C0, and second turning point is at this area marked with a X. Okay, so let's see how I'm going to draw this. Okay, so if we draw something like this, our first turning point is going to be at C0, and that's going to slope something like this to here. It's going to slope upwards. Okay. So that's what our cubic is going to look like. So I know it's a bit messy of a drawing since it's pretty hard to draw on a device, but our rough shape should look like this. So our first turning point is going to be at C0. Our second turning point is going to be at the x-intercept of our parabola, and the parabola is a positive parabola, so therefore the cubic is going to be a positive cubic, which means it's sloping upwards. So having all of these correct features, so that's correct turning point here, correct turning point here, and correct shape, that will get you a merit. For an achieved, you can probably get away with just having you can probably get away with an achieved if you, for example, if you just miss out one of these points, it might still be enough for an achieved, depending on the marking schedule. Okay, so achieved, I'll just put a question mark there since it depends on how the marking schedule is going to be drawn out. So a cubic function, so question E, a cubic function f of x equals to ax cubed plus bx squared plus cx plus d has turning points that occur at x equals to 3 and x equals to -5. Find an expression for c in terms of a. So turning points means that the gradient function equals to 0. So that's what turning points are. So turning points is when f dash of x equals to 0. So therefore we need to find the derivative of f of x to find f dash of x, and we're going to plug in x equals to 3 and x equals to -5. And this will give us an equation that we can cancel out the variables, and eventually we'll get an expression for c in terms of a. Alright, so f dash of x equals to 3ax squared plus 2bx plus c. So if we plug in x equals to 3, so f dash of 3 is equal to 0, since it's turning point, so therefore 0 equals to x squared is 9 times 3 is 27, so 27a, 2 times 3 is 6, so plus 6b plus c. So that's our first equation there. Our second equation is plugging in f dash of -5 equals to 0. So therefore 0 equals to -5 squared is 25, so 75a, 2 times -5 is -10b plus c. since we want an expression for c in terms of a, we're going to manipulate these two equations so that we can eliminate the variable b. So we have 6 plus 6b in equation 1 and negative 10b in equation 2. Our lowest common multiple in this case would be 30. Okay, our lowest common multiple here is 30. So if we multiply this equation by 5 and this equation by 3, we'll see that this will give us the result of, for equation 1, we'll get 27 times 5, so 100. So 0 equals to 125a plus 30b plus 5c. For equation number 2, we'll have 0 equals to 75 times 3 is 225a minus 30b plus 3c. Alright, so now we want to try to get rid of these 30b, so we're going to add these two equations together. So we're going to get 0 plus 0, that's still 0, that equals to 135 plus 225, which equals to 360a. 30b plus negative 30b is just 0, so that's going to be cancelled out. 5c plus 3c is 8c. Alright, so now we have 0 equals to 360a plus 8c. So therefore, if we want an equation for c in terms of a, so therefore we're going to see that negative 8c equals to 360a. So therefore, if we divide on if we divide on negative 8 on both sides, we'll see c equals to negative 45a. That should be our final answer for this question. So c in terms of a, so we have c equals to negative 45a, and that should give us an excellence level grade for this question. To get a merit grade, if you can merit. Okay, so for achieved, if you can probably get away with an achieved just by perhaps getting one of these equations, you can probably get away with an achieved. And if you want a merit grade, it's going to be a bit tricky to find a place where you can get merit. If you can find both equations and maybe like show some evidence of manipulation, you could get a merit. Okay, but I'm not too sure. It's a bit shady at the merit part, but. Alright, that's that question. So question 3. F dash of x equals to 3x squared minus 2x minus 4. That's the derivative of a function f. The graph of f of x passes through the point 310. So find the expression for f of x. So since this is a gradient function, we're going to integrate back to find our original function. So our f of x is equal to the integral of 3x squared minus 2x minus 4. So therefore f of x equals to, if we increase the power by 1, so 2 plus 1 is 3. 3 divided by 3 is just 1, so x cubed. So negative 2x if you increase the power by 1, so 1 plus 1 is 2. Divided by 2 is just negative x squared minus 4x plus c. So the graph passes through the point 310, so we're going to substitute that one in. So 10 equals to 3 cubed minus 3 squared minus 4 times 3 plus c. So 10 equals to 27 minus 9 minus 12 plus c. And we can figure out our c value by moving everything to the left hand side. So 10 minus 27 plus. Should find that c equals to 4. So therefore f of x equals to x cubed minus x squared minus 4x plus 4. And that should give us an achieved grade for this question here. A well surfaces on a still sea. As the well surfaces, a circular ripple expands outwards at a constant speed, so that the radius of the circle is given by r equals to 0.7 t, where t is t seconds after the well surfaces. At what rate is the area of water within the circular ripple increasing 20 seconds after the well surfaces? Alright, so it's always helpful to write down what you know. So first thing you know is that the area of the water of a circular ripple, so the area of a circle is pi r squared. And we want to find the rate of change of the area of the water, so that's the rate of change of area, dA over dt. So therefore you want area in terms of time, but that's perfect since you have r equals 0.7 t. So therefore you can substitute r equals 0.7 t into our area formula, so pi times 0.7 t squared. Therefore a equals to pi times of 0.7 squared, which is 0.49 t squared. So therefore A equals to 0.49 pi t squared. So therefore dA over dt equals to 0.98 pi t. So therefore we can substitute t equals to 20 seconds to find the rate of change of area of the circular ripple. So dA over dt equals to 0.98 pi times 20. And that should give us 19.6 pi. And the unit would be meters per second. Okay, so meters. No, sorry, not meters per second. The area. Sorry, my bad. Area. This is the rate of change of area. So area is measured in meters per second. So that's meters, not meters per second. What am I saying? So area is measured in meters squared. Okay, sorry about that. Meters squared. What am I saying? Okay, area is measured in meters squared. Time is measured in seconds. So this will be meters squared per second. That's what. Okay, meters squared per second. Okay, and if you want to simplify this by multiplying by pi, it's about 60. It's about 61.58 meters squared per second. Alright, and that should be a merit level question. Should be a merit level question. To get it achieved, if you can find the area, achieved could be getting up to this point here, finding an area in terms of time that could get you an achieved. Question C, the graph of the quadratic function h of x together without its gradient function h dash of x are given below. Find an expression for h of x. You must use calculus, okay? So for this question, we're clearly given the equation for h dash of x. We can just use our level 1 knowledge of linear graph to find the equation. Our y-intercept is y equals to 2. And if you find the gradient is always rise over run. So rise over run, that's m. And we know that y equals to mx plus c. So in this case, we have m equals to rise over run. In this case, negative 2 over the run, which is 3. So m equals to negative 2 over 3. And c equals to 2, since that's the y-intercept. So therefore, we can say that h dash of x is equal to negative 2 over 3x plus 2. And we can actually integrate this to find h of x. Okay, so we can h of x is equal to the integral of negative 2 over 3x plus 2. And h of x equals to negative 2 over 3x squared over 2 plus 2x plus c. So h of x equals to negative 1 over 3x squared plus 2x plus c. And to find the c value, we just need to substitute 1 point of this h of x equation. So we see that this parabola passes through the point 0, 4. We're going to substitute this one into our equation to find our c value. So 4 equals to negative 1 over 3 0 squared plus 2 times of 0 plus c. So therefore c equals to 4. And h of x equals to negative 1 over 3x squared plus 2x plus 4. And that should be our final answer for this question. Okay, so this should be a merit level question. And to get an achieved, if you can find the correct integral, that should be an achieved. So up to this step should be enough for an achieved. Okay, so 0, 4. Okay. The function f of x equals to kx cubed plus 9x has a tangent with the equation. The function f of x equals to kx cubed plus 9x has a tangent with a gradient of 15, where x equals to 2. Find the value of k. Alright, so for this question, we just need to find the derivative, and we need to substitute the gradient equals to 15 and the point x equals to 2, and that's just going to leave us k, which is going to find the value of k. Okay, so f dash of x. Okay, so f dash of x equals to 3kx squared plus 9. And if we substitute the gradient equals to 15 and x equals to 2, we should be able to find our k value, since we only have k by itself and a bunch of just constants, okay? So 15 equals to 3k times 2 squared plus 9. Alright, so 15 minus 9 is 6, so 6 equals to 2 squared is 4 times 3 is 12, so 12k. Therefore, k equals to 1/2, okay? Alright, so this question actually just seems like a not merit level, maybe just an achieve level question, to be honest. Okay, achieve level question for finding k equals to 1/2. And question E. A right-angled triangle OAB is drawn within a parabola as shown in the diagram below. 3 possible triangles OAB have been drawn. The point O is the origin 0, 0, and point A can lie anywhere on this parabola above the x-axis. The equation of the parabola is in the form y equals to mx minus x squared, where m is a positive constant. Use calculus to find an expression in terms of m for the maximum possible area of the triangle OAB. Alright, so first things first, we need to find the area of the triangle. So we need to know what the area of the triangle is in terms of the formula. So the area equals to half base times height. So since O is the origin, that's 0, 0, of the parabola, this makes it a lot easier. Since any point on the parabola is just going to be xy, okay? So any point here, for example, that's going to be xy. That's just going to be some xy, we don't know. So anywhere on this parabola is just going to be xy, okay? So therefore, you can actually see that the length of the base of the triangle is actually just going to be x, okay? This particular x value here of a particular point on the parabola is just going to be x. That's the base. In terms of our height is just going to be y, okay? So y is in the equation of the, in terms of the equation of the parabola, okay? So y, it will be our height. And since we're starting at the origin 0, 0, there's no need for any shift. So for example, if we were to start, if the O point was going to be here, then we're going to have to shift it up by 3. And that means we're going to have to, that means the height is actually going to be y plus 3, since we have to shift it up by 3 and then add the y, okay? So, but since we're starting from 0, 0, makes our lives a lot easier since we don't have to shift the graph, and therefore it's just going to be area equals to 1/2 x times y. But we know that y equals to mx minus x squared, so we're going to substitute that one in. So a equals to 1/2 of x, and we have mx minus x squared. Alright, so if we expand this one out, we say area equals to 1/2 mx squared minus 1/2 x cubed. So if we find dA over dx, we should find that this gives us mx minus 3 over 2x squared. So dA over dx equals to 0 at a maximum area. So dA over dx equals to 0. So therefore 0 equals to x. If we factor it out, we'll get m minus 3 over 2x. So therefore x equals to 0. Or x equals to, or m minus 3 over 2x equals to 0. So therefore m equals to 3 over 2x. So therefore x equals to 2 over 3m, okay? So that's one of our points, x equals to 0 and x equals to 2 over 3m. But just consider these 2 points, okay? So just considering these 2 points, 0, 0. If x equals to 0 is a maximum, then technically, if we draw the point 0, 0, and we're starting from point 0, 0, technically the area of the triangle there is 0 units squared, okay, since the 2 points are the exact same. So therefore, this will give us an area of 0 units squared. So obviously, that's going to be a minimum, since any triangle other than that will give us a higher area. So that will be a minimum area. So therefore, this x value of 2 over 3m is going to give us our maximum. So this is going to be our maximum. And all we need to use calculus in terms of m. Okay, so that's all we really need. So x in terms of m here. So we have x equals to 2 over 3m, which is going to give us our maximum area of the triangle. And that should be our final answer for this question. And this should be an excellence level question. To get a merit, merit could be a correct derivative here, could be a merit. In terms of an achieved, if you can recognize that the area is equal to this formula here, that should be an achieved grade there. Is that it? Okay, that's it. So thank you for watching this video. I hope you enjoyed the video, and I